Okay, let's get started. Good morning, everyone. Welcome back. My name is Hong Kim, as you may know, and this course is about selected topics in ICT convergence. And this semester, I try to focus on power system economics. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students, and most of are from my lab. And one student is from another lab. So I'm wondering, you know what this course is about? You don't know? So you didn't read this syllabus before? Okay, then you know what it is. So this is about power system economics. Okay, so you know that this is about power system economics, and you are interested in power systems economics. Can I ask you why?
제가 하는 과제 중에서도 ICT 융합 관련된 과제가 있어가지고 일단은 강의를 한번 수강하게 되었습니다.
Okay, so yeah, this title, ICT융합특론, can cover many different types of topics, but this is specifically focused on power system economics. So is that okay to you?
네.
Really? But it's up to you. Yeah, but this is totally about power system economics. So previously, the name of this course was Power System Economics and ICT Convergence, or something like that. But I changed the title like that because we need to have this course for BK program. And Power System Economics is not quite good for BK program, so I changed the name. But the content is the same as before. Okay. And by the way, because BK encourages us to have English lectures, I will use English, but you may use Korean to ask questions. And if necessary, maybe additional explanation can be Korean. Anyway, so yeah, this course is about power system economics. So first, we have a power system. In Korean, that is called 전력계통. So the reason why we can use electricity is because we have power system. Okay, so we have lights on, and the motors in the factory can run because of power system. And power system economics is a way of operating power system in an economic way. Okay, so because we don't have power system on the graduate course, I do not assume that you know the basics of power system. Okay, I do not assume that you know the basics of power system, but for power system economics, it is not necessary to understand the whole power system because we will focus on the economic part mostly. Of course, if you already know power systems, then that will be better. But even if you don't know what power system is, then it doesn't matter. Okay, so don't be afraid. And I taught this course 7 years ago, in 2016, and this is my second time. So in seven years ago, I used this textbook, Power System Economics, the first edition, and it was written in 2004 by Professor Kershen at the University of Washington, which is located at Seattle. And a few years ago, he published a revised version. So this is the second edition. I encourage you to buy the second edition. I'm not sure whether you can buy it in Korea. Maybe you can order it from Amazon. But anyway, having this textbook is good for you. And after every lecture ends, even if I do not tell you, you must read the required, the relevant chapters. Okay? Otherwise, it's not easy to follow the lecture. And because we don't have TA, that's my difficulty, but I will ask one of you to assist me the setup, the camera, blah blah blah. And about the evaluation, okay, let's talk about that later. So this lecture, we will delve into the power system economics, crucial components in the operation of power systems, and we will examine how traditional monopoly electricity markets are transforming into fully competitive markets. So the traditional monopoly market is evolving to competitive markets in Korea as well. But you will see that different countries have different situations. So it depends on the country and the continents. So power system economics is very different from country to country. European countries, or the United States, or Korea, or Japan, or China, they have different structures. So, so when you read the textbook, you will find two countries which you are not familiar with. The name of those two countries are, yeah, you will find that. So the reason why this author assumes some two non-existing countries is because it is controversial, sensitive, and power system economics is related with politics, policies, and politicians. Okay? So we have many sensitive issues. So that's why the author of this book assumes imaginary two countries where this power system is running. Okay? And yeah, so from monopoly electricity market, we're going to fully competitive market. Well, this is an ideal case in economics, not power system economics, just economics. The fully competitive market is the most efficient market. Okay, and the reason why we are assuming this fully competitive market is because the market is efficient. Efficient means, in our terminology, efficient means optimal. Okay? Optimal means we can produce what we need at a minimum cost, or we can maximize our utility or profits given the cost constraints. Okay? So to optimize the system, we assume, so this is just an ideal assumption, fully competitive market. But the situation in reality is not quite good to accommodate this fully competitive market. So that's why some part is still owned by only a single entity. Okay, so that is a monopoly electricity market. And so we will study fundamental microeconomic elements necessary for this transition. So is there anyone who took microeconomics when you were undergraduate students? Have you heard of what is microeconomics in Korean? Okay, yeah. Then what is the opposite of microeconomics? Yeah, what is the English name for that? The opposite of micro is macro. Okay? So macroeconomics versus microeconomics. But no, this course is about power system microeconomics. But at the end of this course, we will discuss the expansion of generators and expansion of the transmission line. That is not microeconomics because that involves investment. Okay? And that is related with macroeconomics. But mostly we will focus on microeconomics. And in chapter 2 of this textbook is fully about microeconomics. Chapter 2 is not related with power system at all. Okay? So when you study chapter 2, you will have a good opportunity to understand microeconomics. that's interesting in the sense that, previously I studied wireless networks, wireless communication networks, and we had a topic of resource management, the frequency resource, the time resource, or the space resource. That resources should be allocated to users, and that is about optimization. Okay? Resource management is another name of optimization. And economics is a way of allocating resources to users or entities. Okay? So microeconomics is very similar to optimization. Okay? And some of you are taking optimization, introduction to optimization in this semester, right? So, yeah. And this course has some part of this course has optimization, but I don't want to focus on optimization in this course because I assume some of you are already familiar with that. Okay, so rather than talking more about optimization, I want to focus on power system and power system economics. But if necessary, we can discuss the optimization technique here. Okay. Additionally, we will learn about the features of electricity markets and the various forms of power transactions. So, yeah. This part is about a future electricity market, and maybe later, after we cover all the contents in this textbook, you need to read a paper and present that, and probably the interesting topics will include P2P transactions and the management of distribution network using market mechanism. Okay. And we will also explore the roles of participants in the electricity market and the provision of ancillary service for maintaining system stability. How many of you know the meaning of ancillary service? How many of you are new to this terminology, ancillary service? What is the meaning of, what is the English meaning of ancillary? We are not using this terminology in our daily life, so maybe you are not familiar with the terminology ancillary. What is the meaning of ancillary service? What is the meaning of ancillary? Yeah, ancillary means so we will see what it is later. And this is required to maintain system stability. Okay, stability. Now we have the terminology stability. In power system, you may know, you know that power system should be stable, otherwise blackout will occur. Then what does this stability mean? How can we stabilize the power system? The basic premise is that we need to make the generation of the power generation equal to the total load of the whole power system. Otherwise, if the generation is more than load, or if the load is more than generation, in either case, the blackout will occur. Okay? So you know that in a hot summer day, a lot of people are running air conditioners, so we have a power shortage, then maybe the power system can break down, and you can watch that kind of news. But the opposite case can also happen. So we don't have much load, and we have a lot of generation because of the renewable energy. The renewable power is excessively higher than we expect, then no, the total amount of generation is greater than the total amount of load, then no, the power system becomes unstable and blackout can happen. So this generation and load must be equal to each other all the time. Of course, we have some slight margin for that. Anyway, so this ancillary service is required to system stable. We'll see what that is later. With the growing number of distributed resources, here the terminology distributed resources or distributed energy resources. Maybe some of you are familiar with this terminology. This is abbreviated DER typically. And in Korean, this is called 분산차. So this is important in current and future power system. And the reason is because the market, the system is transforming from monopoly to competitive market with a lot of participants. A lot of participants means, okay, you have a house and you have a rooftop solar panel, then you can generate your own power. And if the generation of power is more than your local energy load, then you can sell it to the power grid and you can make money. Okay? So traditionally, we only have a few number of players in the market. A big generator company, nuclear power plant, or coal power plant, or hydropower plant. But now we have many different types of small energy resources, and they are small and distributed. Right? So solar panel, or wind turbine, or fuel cell, etc. So they are called distributed energy resources, or DER, or 분산자. Okay, so with the growing number of distributed resources, including demand response and renewable energy. By the way, how many of you are not familiar with this terminology, demand response? Yeji. Are you familiar with demand response? What is demand response? How many of you are not familiar with demand response? Please respond. 재범? Are you familiar with demand response? No? Then why don't you raise your hand?
지금 이 수업이 저한테 맞는 걸 생각하고 있습니다.
Yeah, that's why I asked you the questions in the beginning of this class. So demand response, okay, so maybe I guess one or two students are not familiar with demand response. But this demand response, or simply called DR, means that demand can be responsive. Or, in other words, it says you can reduce your power consumption under certain circumstances. For example, if the electricity price is very high, you can reduce your power consumption. You turn off your air conditioner, for example. In a factory, if you're an owner of a factory, then if the price is very high, then you reduce the manufacturing, you reduce the power consumption for manufacturing process because the price is too high. Or sometimes the utility company can give you some money if you reduce your power consumption compared to the normal case. Okay? So previously, people assumed demand is fixed and demand cannot be changed because people want to do what they want to do. So they don't want to change their power consumption behavior, their economic behavior. But no, price can change people's behavior, so demand can be responsive. So this concept, demand response, was introduced around 15 years ago. So when I worked at Bell Lab, 2010, it was a new concept, and actually this was my first topic of studying smart grid. Anyway, so demand response is also a kind of distributed energy resources. So generation, small capacity generation can be a DER, and also demand response can be a DER. Anyway, so with the growing number of distributed resources, including demand response and renewable energy, the need for decentralized electricity markets is increasing. So here we have this terminology, decentralized. This means currently in most countries, this electricity market is centralized. There is a one entity who runs the market. Okay? But because we have so many players, we need to have decentralized electricity market. And the example is many retail markets. We have a wholesale market. Wholesale means 도매시장. And the resale market is 소매시장. Okay? But in Korea, we have one wholesale market, which is run by whom? In Korea, we have a single wholesale market, and that market is run by KPX. KPX means Korea Power Exchange. You may know K. What is the KPX, which is located at Yeouido? KRX, I guess KRX, but I don't know what R stands for. Jacob, do you know what KPX, which is for stock trading?
한국전력 말씀하시는
No. Okay. 한국전력 is called KEPCO, Korea Electric Power Company. So this is a utility company. Anyway, the difference between utility company and KPX and the wholesale, the retail market will be clear later. Anyway, so through the study of ICT advancement, the highly competitive market, through the study of ICT advancement, the highly competitive market environment, and the liberalization of the retail market, we will understand the future developments and evolution of the electricity market, including peer-to-peer trading and decentralized distribution system. So here you see this terminology, distribution. Network or system, and distribution network or system. So in Korean, what is it? Yes. What is it? Yeah. So when you drive in a highway, you can see the transmission network, actually, very huge transmission tower. And when you go through the streets in a city, then you can see this distribution network, right? The pole. Anyway, so this distribution system means distribution network. So, course management, prior knowledge of power system is advantageous but not necessary. This course consists of lectures based on textbooks, followed by a review of recent papers, and presentation. So Yeah, you need to present. We will have some kind of seminar, maybe 2 or 3 or 4 weeks, depending on the speed of this lesson. And I'm considering having quiz every week, so that you can at least read this textbook. So yeah, to aid students' understanding. And the scores can be used as a substitutes for midterms and finals, which means we may or may not have midterm or final, I'm not sure. It depends on your understanding. Students are required to read the relevant textbook contents and come prepared for each class in accordance with the course outline. So what is the outline? We have actually, yeah. How many of you have this textbook already? How did you get it?
through 교본.
Okay. How much is it?
기억이 잘 안 나요.
Okay. Okay. By the way, this size of class is not small in graduate school. When I was at Texas Austin, mostly the number of students is less than 10. And also, in Korea, in other universities, the number of students are not quite huge. So I think this is a pretty big class for this kind of specialized topic. Okay, so I think this is pretty good opportunity for us to study this topic. Okay, so I'm planning to put a lot of efforts in conveying the idea and discussing. So the chapter 1 is Introduction to Power System Economics. So chapter 1, we have just 10 pages. So at the end of this lecture or Wednesday's lecture, you are required to read this textbook. Okay. Maybe some of you already knows how to get this textbook in a PDF form. I'm not encouraging you to do that, but I cannot know whether you can get that or not. So it's up to you. And the chapter 2 is about basic concepts from, the chapter 2 is about the markets for groups. The chapter 2 is basic concepts from economics, yeah. So this is not about power system at all. This is just about microeconomics. And I think the concepts here is very interesting. And maybe you know that we have x-axis and y-axis. And we have this kind of curve and that kind of curve. So this is supply curve and this is demand curve. And the intersection of these two curves gives us the price, market equilibrium. But we can say much more than that. Okay, so yeah, that will be fun. And after we understand microeconomics, then we will discuss the markets for electrical energy. The difference between traditional market versus electricity market is comes from the special characteristics of electricity. Electricity or electrical energy can be a good or commodity that can be purchased or sold. But it is related with real power system. This real power system is a constraint, and the constraint we need to satisfy all the time. Okay, and also the delivery of these goods takes no time. It propagates at the speed of light. Okay. Actually, yeah, the electricity propagates at the speed of light because there is electromagnetic wave. So the traditional market and the electricity markets are different because of the physical power system, and so we will discuss what those are. And then after we have this electricity market, and then there are participants in the market. Who sells the electricity? Who buys electricity? And who manages the network from generator to the consumer? Okay. So yeah, there are different players in the market, and yeah, then this part is more about power system because it has transmission network, and transmission networks, high voltage, typically more than hundreds of kilowatt. This transmission network is a very strict constraint of the power system. That means the power flow, I didn't define power flow yet, but anyway, you can easily imagine what power flow is. Power flows. So the maximum limit of power flow is limited by the capacity of this transmission line. Okay, and the capacity limit of transmission line is very crucial because currently, okay, Korea is like that, and this is Jeju Island. More than 20% of energy is generated from renewable, solar and wind, and that is more than the total load of Jeju Island. So from time to time, a lot of excessive energy generated from renewable need to be transmitted to other places or need to be just burned, consumed. So this Jeju Island and the main continent of Korea is connected by two lines. They are called HVDC, high voltage DC. And but this high voltage DC lines has its own capacity. So when the total power flow from here to there or there to here is over the limit, we cannot transmit more power. And that means we have congestion. Yeah, congestion is used in computer networks or wireless networks, but this terminology congestion is also used in power system. So when congestion happens, it affects the price. We will see why. Okay. So in chapter 5, in chapter 5, we will discuss what is the impact of congestion on the price. And chapter 6 is about power system operation. And in the first edition, that chapter, the name of the chapter was System Security and Ancillary Services, but the title is changed to Power System Operation. And also it has the ancillary service part. And this is about optimization. So depending on your knowledge, maybe we also need to discuss the optimization, Lagrange multiplier, blah, 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 but I'm not sure whether, at this moment, I'm not quite sure whether we need to do that. Because around this time, the freshman is also taking optimization course, and then they are familiar with the optimization, so that I don't need to cover it in this course. You know what I'm saying? Anyway, and the last two topics is about investing in generation, so generator expansion, and the transmission network expansion. And these two things requires huge investment, and also it has environmental resistance. What I'm saying is, okay, we have more power plants, like nuclear power plants or coal power plants, but nobody wants to have those power plants nearby me. How many power plants are in Seoul? How many power plants are in Seoul? 0, 1, 2, 3. Please guess. Okay. Why did you pick 4? Any idea? Any other idea?
0개.
0. And who else? Who else? Who else? 민재.
At least one. Because I know 강의님 발전소.
Yeah, at least 1. Correct answer. We have only 1. We have only 1 power plant in Seoul. And yeah, 강의님 발전소. This is very close to Seoul University. And most of you, so some of you went to a restaurant, pizza restaurant. Oh, actually, yeah, all of us went to that restaurant, right? 강의님 발전소 is next to 합정 station, very close. And actually, this power plant was on the ground a few years ago, but it is now in the underground. And the capacity of 강의님 발전소 is how much? Can you guess? I hope you have some rough numbers of power system and Korea power systems. And so in that sense, what is the capacity of this typical core power plant which is located in Seoul? Anyway, we need to have megawatt, right? By the way, you are not. Okay, what is the peak load of Seoul University in hot summer day? Yes, about Seoul University consumes around 5 to 6 megawatt. That is the peak load of Seoul University. What about these generators, this power plant? What is the typical capacity of core power plant? Yeah, 500 megawatt or 0.5 megawatt. Then what is the typical capacity of nuclear power plants in Korea? Yeah, nuclear. 1 gigawatt. Then what is the peak load of Korea in a hot summer day? 민재? I assume you already know all of this number, but it seems not.
I have no idea.
Oh, you have no idea.
What you said.
Guess what is the peak load of Korea in a hot summer day? Hot summer day. 30 gigawatt. Who else?
(500기가와트)
30, 30, 500. One. Okay. Any other guess? 10 gigawatt. Okay. Well, roughly speaking, 80 to 90 gigawatt. is a peak load of Korea, South Korea. Okay. So not more than 100 gigawatt. And that means, hey, if we have 80 nuclear power plants, then we can cover the whole electricity load in Korea. Is that correct? Can I say it like that? Why not?
왜냐면 원자력 발전소 같은 경우는 이게 가동할 때 시간도 뭐 그러니까 시간이 걸리는 그런 자원들이 있는 걸로 알고 있는데, 그래서 그런 시간들을 고려해서 다른 자원 화력이나 뭐 수력 같은 뭐 좀 제너레이트 할 수 있는 빠른 자원들로 이걸 커버를 해줘야 될 것 같아요.
Okay, so Gunju says nuclear power plants need to some startup time. So because of that, other types of generators are required. That is true. And then also, but another thing is that nuclear power plants, it's not easy to change their generation power. This is just a fixed power generator. When you set the power as 1 gigawatt, then it constantly generates 1 gigawatt. If you set it 500 megawatt, it constantly generates 5 megawatt. Okay? It is very hard to change the power, the amount of power of nuclear power plant. So, but you know, our loads changes over day. Right? We have a peak load just before the lunchtime, and it goes slightly, 5% typically, and then goes up again, and then decreases. And the total number of generation, the total number of generating power must be equal to the total number of load all the time. Okay? So the generators need to change their generating powers adaptively. So we need to have another plants, core power plants, or natural gas power plants are very good for that purpose. Anyway, so please remember this kind of number, nuclear power plants, 1 gigawatt, Korea, 80 to 90 gigawatt. Core power plant is just half of this, etc. And the mix of different energy sources is also important, because we cannot have only a single type of generators. So it changes over time, but nuclear, core, and renewable, and natural gas, and hydro. By the way, so the camcorder cannot record this part, right? Maybe it is just up to this point. Check that. Oh, okay. This is so 5 to 7 years ago, the ratio of nuclear core and natural gas and hydro is roughly 4:3:1. But it changes over time, and nuclear is slightly reduced, core is slightly reduced, and renewable is increasing. And you may heard of this kind of catchphrase, RE 2030. It means Korea government wants to increase the portion of renewable energy up to 20% by 2030. So this 20%, currently renewable energy is around 7% or 8%, which is pretty much lower than other European countries or the United States. Except for this Jeju Island. Jeju Island already has 20% of renewable energy. But because of the generation is more than load, the curtailment, we need to curtail the excess power generation. That means you are, this is very hot issue now. So you are owner of solar panel, and then it generates power. Sometimes it generates much power because the sun is very bright. But the power system operator in Korea, that is KPX, and I will explain this terminology shortly. ISO, Independent System Operator. This is a non-profit organization. So they operate the whole power system by balancing the generation and the load equal to each other all the time. So what I'm saying is, so when this curtailment happens, you cannot, so the generated power from your side cannot be delivered to the power system. That means you cannot get money for that. You cannot sell that power to the CAPCO. Then that means you have revenue loss. Then you may think, hey, I have generators and it generates power, then you curtail my generation, then who can compensate my loss? Government? You may ask government to compensate that. But the rules are not determined yet. Okay. Anyway, so currently, because of climate change and climate crisis, and transforming from monopoly to competitive market, we have many issues in this power system economics domain. That's why I want to open this course. And also, we will do some interesting fun researches in terms of P2P trading in distribution network. So some of you were involved in writing a proposal to CAPCO, and the result didn't come out yet, but I'm expecting a good result anyway. Okay, so this is, by the way, so at the end of this semester, maybe 3 or 4 or 2 weeks, depends on how quickly you can cover the contents. You need to make a presentation for the most hot and current topics in power system economics, probably in the distribution network area, like P2P trading, or energy storage, or electric vehicles, or renewable generation, blah, blah, blah. Any questions so far? How many of you are still think, I need to take this course? Only one. How many of you are still think, I need to take this course? It seems like you don't understand my question. Okay, no problem. So, let me stop here, and I will see you on Wednesday if you still plan to take this course. Okay? Yeah, thank you.
That's
Cut.